of the image and kernel. Where has the time gone? My answers are all wrong. Seems like my brain is trivial. Well, I know it's hard to do linear, and that's why I made the song. Hope it'll make you feel better. Don't solve your matrices wrong. Remember how to reduce and to write down your ops. And if the solutions you need, the rank of your matrix is full. If it's not full rank, then linear combo, non-zero kernel, like a projection orthogonally. And if you combine, then you multiply. Inverting the matrix or find a new basis where B equals SA as inverse. If there's similar change of coordinates, trace and dimension stays the same. If the determinant's non-zero, then we know that it's invertible. And if multiplicities are the same, we can also make it diagonal. To find the multiplicity, let's first talk eigenstuffs. ZAX equals lambda x. These are the eigenvalues. Plug in the lambdas that we find and find the kernels again. These are our eigenvectors. Magically they spin S. SDS inverse, it's diagonal, makes squaring easy. And if A's also symmetrical, then S orthogonal or ONEB. I have a matrix trying to make sense of the image and kernel. Where has my mind gone? My answers are all wrong. This is the opposite of trivial. If the eigenvalue's non-zero, then we know that it's invertible. And if the matrix is symmetrical, these orthogonally diagonal. Yeah, I have a matrix. Ooh, yeah. Now please just don't give up, so I can tell you what you need to know. And all of us believe that you won't fail. You already have what you need to know. I have a matrix, I can't find the basis of the image and kernel. Maybe my time's gone, my answers are all wrong. Maybe my mind is trivial. But if my determinant's non-zero, then we know that I'm invertible. And if my matrix don't span all Rn, then I am linearly dependent. And I have a matrix.